The first question, even though the first question, it says like, as I mentioned, it's number 20 on the test, which meant to be challenging. So if you do get the answers like easily, so then question yourself and see if you did something wrong. So because it shouldn't be that simple. So, but at the same time, the question doesn't really require a high school level thinking either, because this is a middle school contest. So it shouldn't have too much like knowledge involved. So we are looking for different real solution, right? If I ask you like there's a like expression right here to the second power is equal to 16. Like if you like find the square of this expression, some people may try that, like even like some people can do this, like x square minus 5 square. Some people are trying this x square minus 5 square or even plus 5 square, but there is nothing like that. So you cannot really square the terms in a parenthesis. So when you have like more than one terms like this, you cannot really do that. But what you can do, you can use the something we call square of binomial to expand them, which does give you a lot of term, which is why it doesn't work nice either. So we should think about like simple approach. What is it? Like I ask you like what number, like if I ask you y squared equals 16, what would you say y would be? Then you probably say y could be 4 or -4, right? But there is nothing really different. Like we have a term right here, like expression to the second power is 16, which means the x squared minus 5, whatever that is, has to be 4. Or x squared minus 5 has to be -4. Because if you square 4, you get 16. If you square -4, that's also like 16. And by using this, what do you guys think? Like, do we have anything helping from here? So let's see. Some people may have something. So I guess that looks good. Like you may try to add 5 to both sides. Okay, so if you add 5 to both sides in this equation, you will get x squared equals 9. And if you add 5 to both sides, you got x squared equals 1. But the square of something is 9, so that means could be 3 or -3. If you square x to get 1, so this could be 1 or x could be -1. So we do have 4 solutions. Okay, so which is expected because there is something we know, like we will see maybe in polynomial. Like when you have some like polynomial, like degree of 4, you do expect 4 solutions. Some of them may not be real number, but still you do expect at most 4 solutions. So when you expand this one, you have x squared to the second power, which will be x to the 4th power as the largest power. So you do not expect to get a solution at all. Okay, so which is why you could just cross 8, but I think this is reasonable. The answer is just 4. The numbers like proper fraction, right? Like 5 over 19, 7 or whatever. Like, but the difference between the numerator and denominator, like in this case 14, in this case 14, this is also 14. Like the difference between numerator and denominator is 14, which is also another relation that we have in the problem. So what I'm going to try is this: 1 minus 5 over 19 and 1 minus 7 over 21. 1 minus 9 over 23. Like if you do this, this is 19 over 19, subtract 5, which is 14 over 19. And then this is going to be 21 over 21, subtract 7, so you will get 14 over 21. And then this is going to be 14 over 23, which is interesting. So you divide the 14s by the different numbers. Like if you divide by larger number, like 23, you get a smaller number. So this fraction is smaller. But how we get that smaller number? When you subtract 9 over 23 from 1. So like we are subtracting this like from the same value. If this number, like if this fraction is the largest, that means this number should be smallest because we are subtracting from the same number. Okay, so I'm not sure if that makes sense. So if this fraction is smaller than the other fractions, which is because we are dividing the same number by the larger value, so 14 divided 20, like divided by 23 is larger than 14 divided by 19, because you are dividing the same number by the bigger value, so which will make it smaller in terms of fraction. So if this is like larger, that will happen if this 9/23 is bigger, because you take from 1 for all these fractions. That means if this is like bigger, that means this is gonna be like smaller. So you can kind of go with it as well. So from the choices, like the 9/23 is the largest, 5/19 is the smallest, and then you can get the middle one as 7/21. So you could try something similar to this as well. But what else can we try? Like, is there another way we can really attempt this problem? Like, you can try finding common denominator, even though the denominators are not really nicer. You can attempt to find the common numerator instead, which is a bit easier. Like, but you don't want to do all three at the same time. Like, what I mean by, you can just take the first two fraction and find the common numerator of the first two fraction and compare which one is larger. And then take the last two fractions and compare those two, but making common numerator. And then you can get what you want. Okay, so that could be another way to look at it. But anyway, I'm gonna leave those for you to do it, actually get the same result, okay? So let's attempt the next one. We have the Ralph went to store and bought 12 pair of socks that cost $24, okay? Which looks like cheap. The sum of those here is just $1. Some of them is $3 and some of them cost $4. Yeah, awesome. That is correct as well. And like, we don't really know like how many of each type, right? So let's call this is A, B, C. Like if you get like A of these, like socks that cost like $1, so you will get A times 1. And if you take B of these like socks that cost $3, so that should be 3 times B, and then 4 times C. So this is add up to 24. But at the same time, the number of like pairs is 12, right? So which is why A plus B plus C is 12. So like we have 2 equations, but we do have 3 unknowns, which doesn't look like we have enough equation. So we have at least 1 pair of each type. So like if I want to subtract this equation from this equation, like let me write this, A plus B plus C is 12. If you subtract this from this, so A's will cancel. You got 3 minus B, which is 2B. 4 minus C will be 3C is equal to 12. Okay, so we are looking for the number of pairs for like costing $1, right? But how many pairs of this? Okay, like you have to have integer values for B and C, because B and C represent the number of pairs. Like, and if you want to choose like 4 for C, that's 12, so which means B has to be 0. But I do know B has to be at least 1, so we cannot be choosing this as 4. So we can just go with 3. But if I go with 3, that's 9, but I cannot have a whole number for B because that will be 1.5. So, but if I choose 2, maybe that's gonna be 6 to get 12. So I should have, this is 3 as well. So that is 3 and 2. And if this sum of these is 5, so B and C, so these two guys is 5, so A plus 5 is 12, so A is 7. And that is the number of like pairs of socks that cost $1. The first thing we have to see in this problem is actually seeing the similar triangles. Like if you kind of don't see it, so that problem is you'd like to review the similarity a bit. But what I mean by the similar triangle, like since we are given like DE and BC is parallel, so this segment and this segment is parallel, so we have a lot of angles are equal. So like this angle right here is gonna be same as this angle, because this DE and BC is parallel, so those two angles that I marked in red is corresponding angles. They are in the same location. So then the same reasoning, these two angles are also corresponding angles, they are also congruent to each other. They are equal to each other. So that is something. And also we are told EF is parallel to AC. So which is kind of the same reason. This red angle has to be same as this angle. So because this line is this parallel to this one, so this angle F is congruent to angle C. And like the angle right here, which I didn't name it, but if I want to name it, so this guy has to be same as this guy. The reason is the same thing. So those two angles are corresponding angles in between two parallel lines. Okay. Like, why do I label these angles? Because if you look at the now, this DAE and then FEB or ABC, all those three triangles has the same three angles, even though you don't know their angle measure, but you do know this is like angle, the red one with one tick mark, and then there's a 2, and then this is with dot. So those three angles are actually the same as these three angles in this small triangle, and the same thing with the ABC, the larger triangle. So since all those three triangles are having same three angles, which will tell us they are similar. So if they are similar, then we have a relation between their areas. Like, what is the relation? The relation is the area of their like ratios is the square of the ratio of the similarities. Like in this smaller triangle, the side is 1 unit, which is like, if you look at this one, opposite this angle, and the same angle in the other triangle is opposite to 2, which means 1 and 2 is actually the ratio of those two triangles. In the largest triangle ABC, the same angle C is opposite to AB, which is 3 units as big. So meaning that the ratio has to be like this. Let me write this, like the area of ADE divided by ACB is equal to like area of this triangle, like this corresponds to 1, and the same angle at bigger triangle correspond to AB, which is 3 units. This ratio has to be square. So ratio of this square is gonna be ratios of those two triangles area. Okay, so again, this is something we have when you have two figures are similar. Like if two figures are similar by K, then the area ratio will be K squared. So if you look at the similar reasoning like EFB, so let's say this is EFB, triangle EFB, area of this triangle, over area of the ACB. When you take this ratio, so this side is 2, and the corresponding sides in the larger triangle is AB, which is 3. And if you take this ratio to the second power, you do get area ratio. So if you look at this one, so this is 1/9, and this is 4/9. So meaning that the whole region is, let's say, 9 units square. That will tell us the E like FB, which is this region, maybe I should write it, is gonna be 4 of these. So if I call this is 4A, the area of the ABC will be 9. And if ABC is 9, so ADE, which is the smaller one, has to be only 1, because that's 1/9. So this is 4, this is 1, this is add up to 5. So remaining 4 should be this region. So that's 4. So because we have to get total 9, and the ratio of the CDEF is just 4 divided by ABC, which is 9. So 4/9 is the answer. What we can do, like I will try 2 different ways, and if you have something else, please let us know. The first thing, I'm gonna make an equation, right? We don't know number of like gold coins. We don't know the number of chests either. So I'm gonna call number of chests like is C. Okay, so this is, let's say, number of chests. And then let's say G is the number of coins. Number of gold coins. Okay, so if you are trying to put like 9 gold coins in each treasure chest, each will have 9 of them, right? But we are told there will be 2 treasure chests empty. So be careful. So the number of chests will be empty is 2, which means So if you have total of like C of those chests, treasure chests, you do have actually 2 lesser of those completed, like filled with those coins. So meaning that the number of coins, let's say that's G, has to be the 9 times, maybe I should use different variable because 9 and G look the same, but it's fine. Has to be C minus 2 because the number of like treasure chests is C, but we are gonna have 2 of them is empty, which means there will be only C minus 2 of them will be filled with those like gold coins. So then G is the number of coins should be 9 times C minus 2. Okay, that's something. If you look at the second statement, if I put 6 gold coins instead, okay, then I will have 3 gold coins left. So which means each chest will have 6 of them, which is gonna give me like 6 times C because each chest will have 6 of them. And then I will have 3 more gold coins left, which is gonna be the same as this guy. So again, I hope this equation really makes sense because if you really can get the equation that I have now, then the rest just easy enough. So from here, so since both sides like equal to G, so the right side should be equal. So if you multiply 9 by those, you will get 9C minus 18 equals 6C plus 3. Subtract 6C from both sides, that's 3C. Add 18 to both sides, that's 21. So C is going to be 7. So again, this C, like 7 is not one of the choices. If there was a choice like 7, you have to be careful because that's not what they are looking for. Number of coins is what we are looking. So you can plug it right here or plug it right there. C is like 7, so that will be 5 times 9, which is 45. Or C is 7, that's 42 plus 3, that's also 45, which has to be, otherwise there is something wrong. Like this is one way I can do this problem. But if you couldn't come up with this idea, just look at the choices and use the choices. Like, okay, so let me clear that mess and then I can show you what I mean by that. So you could have done this, like, let's say you have no idea, like choose this, for example, let's see if it's right. So if you place 9 gold coins in each treasure chest, and then you will have 2 left, like 2 left empty, right? Which means we are gonna have only like, how many? Like if you want to get 9 gold coins, you should have 3 times 9, which is like 27. So only way that will happen if you have 3 chests, if there is like 2 empty, that means total has to be 5 based on 27. But let's think about this, like if this is 5, but if there is like 6 coins in each treasure chest, and then based on that, we are saying 27 is divisible by 6, but we should have 3 left over, which means if you subtract 3 from 27, that's 24. And if you divide 24 by 6, that's 4, meaning that there should be only 4 chests. But based on the first statement, we got 5 chests. But based on the second, we got 4, which is not the same. So you can eliminate this choice. And you can try this one. And we already know this is the answer. But let's say 63 is the answer. Then you can just put 9 gold into 7 chests. And if there's 2 more left, that will be 11 in total. And if you put 6 onto each of those 11, that's 66. Plus 3 is 69, but that was 63. So as you see, that doesn't work. So you can kind of choose those choices and try every single one of these until you get what you want. In some cases, that's okay if you are not able to make an equation. But we already did the equation thingy, so we are safe. But still, you could have just used the choices. Since we know that Hannah shows her score, okay, to other 2 people, and then other 2 people doesn't like show that. And then what we know that Cassie says, I didn't get the lowest score. Like how she knows that? She, like Cassie, like sees only her score and Hannah's score. So if her score wasn't the lowest one, that means Hannah's score should be lower than like her score. So which is why we can say H has to be smaller than C, like basically. And same idea, I didn't get the highest score, so Bridget says, if that's the case, the Bridget like scores, like her score should be lower than Hannah's score. So which is why we got this one. So if you combine those 3, so I guess that is the highest is the Cassie, and then Hannah is the middle, and then Bridget is the lowest. But be careful with the ordering. So because if you look at the some other ones, so you may confuse, but I think this is good. Whenever you have some like numbers like in geometry, so especially if you are looking for the size, I will ask you to think about the Pythagorean triples, which is really useful as we've seen a lot. So just a reminder, so 3, 4, 5 is like one of the most famous ones, and then we have 5, like 12, 13. So we had 8, 15, 17, and we have 7, 24, 25. So these are the mostly useful triples that we've seen a lot. So why this is important? Because if you do recognize those, you don't have to use a Pythagorean in a lot of cases. So what I will do, I will drop the altitude from B to base a DC, and then I will do the same thing with the other side, so we can get some right triangles. So when you do so, this is 90 degrees, and this is 90. Since this is given as 12, so this is also 12, and this is also 12. So like when you have any triple like this, you may multiply those numbers by anything to get another triple. So if you multiply these by 3, you get 9, 12, and 15. So 15 and 12 right here, which means this piece has to be 9. You may just use the Pythagorean to get that 9, but you don't need it, because if you see that's the triple that you see, you can just do that. And then this is 20, which is like 4 times of this. If you multiply 4 by 3, which is 12, 4 by 4 has to be this side, which is 16. And if you don't recognize that, then Pythagorean, what you're gonna go with. And now we got that's already. So since AB is 50, which is gonna be this distance is also 50. So now you want to find the area of the trapezoid. You can just remember the average of the parallel sides times height is the area, which is going to be the AB is 50. And this is 16, 9, and 50. If you add 16 and 9, which is 25, plus 50 is 75. So DC is 75. So if you take the average and multiply this by height, so you will get 750. Okay, so that's one thing you can do. But if you don't remember the area formula for a trapezoid, as you may try, you may find the area of the triangle first, which is going to be 9 times 12 over 2. And then area of this rectangle, which is 12 times 50. And then area of this triangle, which will be 12 times 16 over 2. If you add those, so you will still get the same result. But either one is okay. But I like you to remind the triples, which is gonna save a lot of time. Okay. The reason why we divide by 6, because for us to get a race, we need like 6 people, right? Because there's only 6 lanes. So you just need to divide to 16 by 6, which means there will be 36 group of 6 people, and there are 36 races basically in that case. And each race will have a winner, and that means there are 36 winners from those first 6 groups, okay? Group of 6 people. And then of those 36 people, so you're gonna divide by 6 again to make another races between those 6 people. So that's why we just divide by 6 again. That will make another 6 different race. And of those 6 different races, there will be only one winner. So that means there are 6 people. That second 6 just means that's the 6 winners. And then those 6 winners will race again, which will give us only one winner, which is the last one. And if you add these, that's so. But before I do this problem, I will clean the this piece. The reason why I'm gonna do this to show you a approach, okay? Like you can still do this kind of approaches on actual tests if you have no idea, and that's okay. So what I'm gonna try, when you have 4 layers, it was kind of complicated, so it wasn't too simple. So which is why I wish that was only 2 layers like this. So based on this, I can just list everything possible. Like I could have like plus. And then if this is plus, we are just like, make sure you remember what we are doing. So we are just like what we are doing is basically, if they have the same sign, we get a minus. If the cells have a lot of different sign, we get minus. If they same sign, which is plus, like we just basically multiplying, right? So if these two are positive, this is positive. This is one thing you can have, or you could have this is negative, so this is going to be positive. So if you like to get the top as positive, so you have two different ways to start with if you have only two layers. That's not too bad, right? So two ways to start with. But how about if I pull these guys and add one more layer? So let's try one more layer, and then I will add two more after. So if I have this much, like when you have only two, right, layers, we had two different ways to start with. But now if there's only like three layers, like just imagine like this is positive and then these two are positive. So we are gonna look into that negative option after. So to get this positive, so this could be negative. This could be negative, all three is negative. This is one thing you can do. But at the same time, if you want to get the, this is maybe positive. Okay, so this is negative, this is positive. So if you multiply, you get negative. So this is going to be negative because they are opposite sign. And the same thing, this is going to be negative. I mean, this is going to be negative, right? And then this is going to be negative if they are opposite. But since these two are negative, so that will be positive. So which means, like, if this is positive and then these two is negative, then still a positive. So which means if we start with this, like negative plus negative, this is one thing you can start with if there's only three layers. Or we already have negative, negative, negative. So if all three is negative, so you could have positive at the top. And then there is two ways. But you could have done this like with the like negatives as well. Like if this was positive, that's good. But what else do we have? Like, can I have some positive? Like if I have this is positive, then this is gonna be positive, this is positive. The top is still positive, which means you could have positive, positive, and positive as well. So you have three already. And then what else do I have? Do I have anything else? Like, can I have maybe like this guy? Let me change the color. So if I have this is negative, we already have this one, right? And then maybe this is a positive, and this is middle one is negative, and this is a positive. If this is the case, negative and positive, so this will make negative. Negative and like negative and positive, this will make negative. So two negatives will make positive, which means you could have just start with positive, negative, and positive. So this wasn't kind of that clear, but like this way. So positive, negative, and positive. Since these two are opposite, so that's negative. These two are opposite, that's negative. These two the same, so that's positive. So you could just start with this, which means there are four ways to start with if there's one more layer. Look at the pattern, like every time when you add one more layer, you are actually doubling number of things. And I'm going to ask you to think about why you are actually doubling. You are not just increasing by two, you are actually doubling. Because every choice that you start with in the previous case, you are actually getting two more ways to get the next layer. So like if you were to increase the layer one more time, so which is what we are given, then to get this negative, there will be two different ways to get this one. Okay, so which means if you had four different ways to go from here to here, and if there is a two ways to get this negative from the lower level, you are actually doubling every time. So not increasing by two. Since we have like this level, we had two, this level was 4, and this level should be 8. If you continue this one more, so you could get 16, but for now, that is 8 ways. And if you don't see this immediately, you can just start listing with the smaller cases and see if there's a pattern. So which I was trying to do as well. But there are some other ways that I like you guys to try for this question, because there can be some different approaches as well that could be done. But I think this is something. So let me start with this one. This looks a bit challenging. So like, let's assume this is the park, okay, city park. Okay, and like she lives 2 blocks west. Like think about this way. So let's say this is like north, and this is like east, and this is west, and this is south. Okay, like if she lives 2 blocks west, so like from the southwest corner of the park. So this is the southwest corner, and she lives two blocks left. So I'm gonna go with like 1 unit right here, and 2 units to the left, and then 1 block south. So which is something right there. So just imagine there is a like the blocks like this. Okay, so let's say this is her house. Okay, so that's her house, and her school is 2 blocks east and 2 blocks north of the northeastern corner. So this is the northeast part. So it's gonna be 2 blocks east. So it should be 1, 2, and then 2 blocks north. So it will be like this. So you could have something like this. So just imagine this is the streets. Okay, this is kind of the visual picture, right? So, but based on this, the question says, on school days, she bikes on the streets to the southwest corner of the city park. Okay, so this is the southwest. So she starts from here, so she just bikes to get this point, and then takes a diagonal path. So let me show you that with different color. So she takes diagonal path so through the park. So to make it a bit shorter path, so it looks like this way. Okay, so I'm gonna call this is like A. I'm gonna call this point as B. Let's say this is C and this is D. So she has to go from A to B, B to C, C to D. And the question is asking, what is the number of different paths that is possible for her? Like, I'm not sure if you remember or if you've seen something we call the water pipes. This is actually a good question for that. Like, we can just go ahead and count them, but let me use the water pipes approach. So if you never heard that before, so maybe useful now. Like, from the point A, I can go up, which is like I can go this straight path, which is one way to go from A to this point. But if you were at here, so you can just continue here. That's one way to achieve from this to this. But at the same time, I can go from A to this corner, which is only one way to go from like point A to here. And this one can go up, but this one can go to the right, which means this intersection has two different previous steps. Like you could just go this way, or you could go this way, which means at this corner, I will say this is 2. 2 is just some of those previous steps, basically. And this one can continue here, so that's still 1. But this one can go up, but this 2 can go to the right, which means at this point B, there are 3 ways to go from A to B. So you can list them if you don't like this water pipes yet. So you can go, this is 1, and this is 2, or you can just go this way, which is 3 ways, which wasn't too bad. But if you have more like the blocks, then you could probably use the water pipes only. So now at this point B, okay, from like I cannot go this way because we are told we are gonna take the diagonal path, so which has to go from B to C. This 3 goes to here only 3 because it doesn't really change. Just 3 just straight continue. But right now from here, so you can go up, so which is 3, and then this 3 can go right, that's 3. But this 3 can go right, and this 3 can go up, which is gonna be 6. And then this 3 goes to the right because there's nothing you can add up. And then this 3 goes up, and then this 3 goes right, and this 3 goes up. So this is the intersection, which is 9. And then 6 and 3 is also 9. And then this 9 can go up, right, and this is up, so which is add up to 18. So you could just do like water pipes approach, which is you are adding all the previous steps at every intersection. And that is 18 ways to achieve this. But for this question, you don't have to use the water pipes. You can just go ahead and count them carefully. How this is gonna look like. We already know from like A to B. So let me do this, A, B, C, and D. So from A to B, there were like 3 ways. We already count like by counting, like I can go this way, I can go this way, I can go that way, which is 3 ways. But from B to C, there's only one way, which is straight diagonal. Since we are not allowed to take these sides out of the part, so just diagonal path, that's only one way. But from C to D, like you can kind of go ahead and count those as well. So, or you can just use the water pipes only in this region. So you can say, I can go 1, and then I can go 1. Like I just, let me just do the water pipes individually right here. So let's say this is like the point C, and this is D. And if I want to use the water pipes only in that region, I can. So let's say this is 1. So this is going to be 1. This is going to be 1. Because this can go this way. But at this intersection, this can go this way. This can go this way. So we don't want to go, let's say we have this one go to the right, right? If you go up, that's 2 plus 1, which is 3. But this 3 shouldn't be going backward because it will make longer path, which is why we are told we want to get the as short as possible. So we are not going to go to left. We are not going to go downward. So we are going to go up and right. So, but now this one can go up. So 1 goes this way, 2 goes this way, which is 3. 3 plus 3 is going to be 6, which means from C to D, if there's only this space, there is 6 ways to go. So if you want to go from A to D, passing through B and C, you have to multiply these numbers 3 times 1 times 6, basically. And that is 18. So you could have just do this way as well, but I hope that makes sense.